Good day, students. Welcome to Mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 6 to 10 of the June 2019 Geometry New York Regents exam. As with previous installations, this is a step-by-step consideration of the steps involved in solving every problem. If you like a quicker coverage of this presentation, feel free to visit our website at Mathgotserved.com under New York Regents. In that at that site, you'll be able to gain access to the transcripts of this presentation. Don't forget to subscribe to our channel so that you can get updates to the remainder of this review series. Alright, let's take a look at question number 6. In question 6, we're being assessed on how to find the volume of a right pyramid. Question 6 reads, a tent is in the shape of a right pyramid with a square floor. The square floor has side lengths of 8 feet. If the height of the tent at its center is 6 feet, what is the volume of the tent in cubic feet? Okay, so what are we looking at here? We're looking at a right pyramid with a square floor. So let's go ahead and sketch it. Alright, so we're going to go ahead and draw the sketch of a right pyramid, and then we'll look at the formula that we can use to calculate the volume, okay? So for a right circular pyramid, the altitude is basically right at the center of the square base. Alright, so let's go ahead and sketch the right pyramid real quick, just to give you a visual as to what we're working with. Alright. So these are the first two faces, the faces that are facing us. Of course, we have two faces on the other side that we can't see. So let's put so you have a face to the left and a face to the right, and of course the base is a square. Okay, so we have a square base, something like that. Nothing perfect. This is just a sketch. Okay, all right. So there goes our square pyramid, and a cool thing about the square pyramid is that the height, the altitude of the pyramid goes right to the center. Okay, so if you look at this right here, this angle is going to be 90 degrees. So this is basically the altitude or the height of the pyramid, of the right pyramid. Okay, all right, so let's label it. The sides of the square base, we're going to call those S. So this is S, S. And then the height of the pyramid, that is going to be H. Okay? In this problem, we're told that the square floor has side lengths 8 feet. Okay, so this is 8. And 8 is 8 all around because all the four sides are congruent. That's what a square is. Okay? My sketch is horrible. Doesn't look like a square, but that's a square, right? And then the height of the tent at its center is 6 feet, so h is equal to 6. Perfect. So now let's take a look at what the formula is. Okay, so the formula for computing the volume of a right pyramid. What's the formula? The formula is V equals 1/3 of the area of the base, multiplied by height. Okay? This formula is very similar to that of a cone too, 1/3 of area of the base times height. Anyway, so what's the area of the base here? The base is a square. So what is the formula for the area of a square? The formula for the area of a square is simply s squared, correct? So we're going to put that in here. So our formula becomes V equals 1/3 the area of the base, which is s squared, multiplied by the height h. From the information that we're given, we know that s is 8, h is 6, and volume is what we're looking for. Okay? So using the formula V is equal to 1/3 s squared h, we're going to plug in these values into this formula. So we're going to have 1/3, s is going to become 8, 1/3 8 squared times h, which is 6. Now we're going to use order of operations. Please excuse my dear and Sally to evaluate this. Do the exponents first. So 8 squared is 64 times 6. Okay? So we are just multiplying here. So multiplication commutes, so it doesn't really matter the order that you execute your multiplication in. 3 goes here once, so and 3 goes here twice. And then you just multiply 64 times 2, and you end up with 128 cubic feet as the volume of your right pyramid. Okay, the volume of this tent, which is a right pyramid. So that's basically how you calculate the volume of a right pyramid. All right, let's take a look at question 7. In question 7, we're going to be assessing how to identify dilated lines using the slope of the image line. Okay? Question 7 reads, the line negative 3x plus 4y equals 8 is transformed by a dilation centered at the origin. Which linear equation could represent its image? So we have 4 options here. All right, so to help us solve this problem, we need to know what the relationship is between a line and the line after it's been dilated. Okay, the image line and then the object line upon dilation. Now let's go ahead and write down what the connection is, something you want to keep in mind. You want to note that the slope of a line is preserved, basically is unchanged under dilation centered at the origin. Okay, so the original line and the image after dilation, they still have exactly the same slope. So what we want to do in this problem is we want to find the slope of this original line and then see which of these lines has a slope that matches that, and that would be the correct answer for us. Okay, all right, so let's go ahead and let's identify what we're about to do. We're going to find the slope of negative 3x plus 4y equals 8. Let's find the slope of this line. Okay, all right, there are 2 ways we can find the slope of this line. We can use either the standard form to find the slope, or we can use the slope intercept form. We're going to be going over both methods in this presentation. So let's take a look at the first method. Method 1 involves finding the slope using the standard form. Okay, so how do you find the slope of a line using the standard form? Well, you need to know what the formula is, right? So the formula is as follows. What is the slope for a standard line, a line in standard form? The slope m is equal to negative a over b. Okay, where we have the form ax plus by equals c. The nice thing about this formula is that it is much faster than the other method. That's why we're doing this one first. Okay, all we just have to do is identify a and b, find the negative quotient of a and b, and that is the slope. Alrighty, so in this particular function that we're dealing with, we can clearly see that a is the coefficient of x, which is negative 3, and b is the coefficient of y, which is 4. So the slope, you gotta be careful here because one of the values is negative. Alright, is minus, a is negative 3, so use that parenthesis to avoid making mistakes, minus negative 3 over b, which is 4. Okay, and then when we simplify this, minus times minus, you slash and dash, you get the slope of 3/4. Alright, so let's use the second method. to find the slope. If you don't like this method that we just used, we're going to use the second method, method 2, which is the slope-intercept form. So how do you find the slope of a line if it is in slope-intercept form? Well, the formula is as follows. The slope is just m, where you have the form y equals mx plus b. So if you can get the line into slope-intercept form, it's easy to easily determine the slope and the intercept. That is why it's called the slope-intercept form. Okay. In this particular problem, we are given the standard form, so we have to do some work here to transform it into the slope-intercept form so that we can find the slope. Okay, so we have standard form. We're going to do a transformation right here. Okay, so what are we doing? We want to get y by itself. We can accomplish this in 2 steps. We're going to subtract 3x, add 3x to both sides and get rid of 4. Okay, all right, so let's do it. You got to do some algebra here. Add 3x to both sides. And what does that give us? If you add 3x to both sides, you're going to have 4y is equal to 3x plus 8. And then the last step, you divide every single term by 4. Divide by 4, 4, 4. And that will give us our slope-intercept form. All right, so our slope-intercept form is going to be y equals 3 over 4, x plus 8 over 4 is 2. So as we can see here, the coefficient of x is your m. All right, so m, which is your slope, is 3/4. And we can see that our slope values are both the same. So whichever method you prefer. All right, so the slope is 3 over 4, 3/4. So the line that could represent the transformation of the original line by dilation centered at the origin is the line that has a slope of 3/4. So what are we going to do next? Well, we have to find the slope of each of these lines. Okay, so for the first one, is all already in slope-intercept form. So all we're looking at is the coefficient of x. The coefficient of x is the slope. Okay, so this is m right here. This is m, this is m, and this is m. Let's write it out. So for the first line, m is 4/3. For the second line, m is 3/4. For the third line, m is the slope, -3 over 4. And then for the last line, m is -4/3. So which one is the correct one? Ladies and gentlemen, the correct answer is option number 2 because it has exactly the same slope as the original line, -3x plus 4y equals 8. Okay? So that's how you identify dilated lines using the slope of the original line. Now, we would like to know what you think. Now take a look at these 2 methods that we used to find the slope of the line. The standard form approach and the slope-intercept form approach. Which method do you prefer and why? Let us know by posting a response to the comment section below about the method you prefer for finding the slope of a line given in standard form, and tell us why you prefer that method. All right, let's take a look at question 8. In question 8, we're going to be looking at how to prove that 2 triangles are congruent. Okay, so question 8 reads, in the diagram below, segment AC and BD intersect at E. Question, which information is always sufficient to prove that triangle ABE is congruent to triangle CDE? Okay, so I want to show that the 2 triangles are congruent. Now you got to remember the postulates and theorems to establish congruency. All right, so there are 4 of them that we're going to be using for this particular problem, let's go ahead and write it down. So cases for congruency are as follows. So to show that two triangles are congruent, you could use either the SSS postulate, you could use the SAS postulate, you could use the ASA postulate, or you could use the hypotenuse, the HL theorem. Alrighty? Okay, so these are the only cases that you can use to show congruency. Now let's take a look at number 1, 2, 3, 4, and then we're going to apply the conditions given to the pair of triangles and see which one satisfies one of these cases. In option 1, you're told that segment AB is parallel to CD. So let's use the first diagram here on the right for option 1. Alright, so if AB is parallel to CD, that means this line right here is parallel to this line. If you have two parallel lines cut by a transversal, you know that alternate interior angles are congruent. So this angle is congruent to that angle right there, alternate interior angles, and then this angle right here is congruent to this angle right here. We know that these two angles are congruent because they're vertical angles. Ladies and gentlemen, what do we have here? We have angle, angle, angle. Okay, so this is AAA. Is angle, angle, angle sufficient to prove congruency? Look at the list. The answer is no. Let's move on to option 2. Segment AB is congruent to CD, so AB is congruent to CD, and segment BE is congruent to segment DE. Is this sufficient to show congruency? We know that these two angles are vertical angles. That will always be the case in all of them, okay? These two will always be congruent because they're vertical angles. So that gives us an A. These two sides are congruent. That gives us an S. And then these two sides are congruent. That gives us an S. Okay? So whichever way you want to read it, you can read this as SSA or ASS. Are any of these sufficient to prove congruency? If you look at the list, the answer is no. This is not sufficient to prove congruency. Option 3, E is the midpoint of AC. If E is the midpoint of AC, that means that E is going to be at the center, so it's kind of like a point that bisects this segment. So this side right here, AE will be congruent to EC by definition of midpoint. Alrighty? So since these two sides are congruent, we have side, and then since these two angles are congruent, we have angle. Okay? So in this particular case, we have SA or AS. Are these congruent to prove that these two triangles are congruent? Look at the list. The answer is no. So our correct answer should be option 4 by elimination. But let's prove it, okay? Option 4 says that BD and AC bisect each other, so that tells us that BE is going to be congruent to ED, and AE will be congruent to EC. What do we have? We have sides, a pair of sides that are congruent, AE and EC, two pair of angles that are congruent, A, and then two sides that are congruent, S. SAS. Is this a congruency postulate? Absolutely. SAS is a congruency postulate. So with this diagram right here, if BD bisects AC, we have side angle side, and that is sufficient to prove that triangle ABE is congruent to triangle CDE. Okay? So that is how you prove that two triangles are congruent, at least one of the ways. Alright, let's take a look at question number 9. In question 9, we're going to be assessed on how to use the cofunction identities for sine and cosine. Okay? Question 9 reads, the expression sine 57 degrees is equal to, so which of these is it equal to? So first thing you want to remember is when you think about cofunctions, you want to think about the word complementary. Alright, so do you remember what complementary means? Two angles are complementary if they add up to 90 degrees. Okay, so complementary angles add up to 90 degrees, or yeah, and then supplementary angles add up to 180. So theta, if you have one angle theta 1 and that angle is equal to 90 minus another angle, so theta 1 is equal to 90 minus theta 2, this automatically tells you that what? They are both complementary. Okay, if theta 1 equals 90 minus theta 2, then theta 1 and theta 2 are complementary. Alright, how is that possible? Well, if you have theta 1 equals 90 minus theta 2, and you add theta 2 to both sides of the equation, what do you get? If you add theta 2 to both sides of the equation, you get the following equation. So let's do that. So if you add theta 2 to both sides of the equation, you get theta 1 plus theta 2 equals 90. And that is what it means for two angles to be complementary. Alright, so with that in mind, let's write out the formula. All you need to know to do this problem is the formula, okay? The formula for cofunctions. So formula for cofunctions for sine and cosine. Okay, so remember, cofunctions indicate complementary angles. That will help you a lot. Sine and cosine. Alright, so for sine, we have sine theta is equal to cosine of the complement of theta. The complement of theta is simply 90 minus theta. That's what it means to be complements, okay? And then cosine theta is going to be sine of the complement of that angle, which is 90 minus theta. So for this particular problem here, sine of 57 is simply equal to cosine of the complement of 57. What is the complement of 57? 90 minus 57. Okay, so sine of 57 is equal to cosine of 90 minus 57 is 33 degrees. The answer to question number 9 is option number 2. Okay, so that's an illustration of how to use the cofunctions identity for sine and cosine. Alright, let's take a look at question 10. In question 10, we're going to be assessed on how to find the volume of a hemisphere, okay? So question 10 reads, what is the volume of the hemisphere that has a diameter of 12.6 centimeters to the nearest tenth of a cubic centimeter? Alright, so before we get started, we're going to write down what the formula is. And before we do that, let's take a look at what a hemisphere is, okay? So let's say you have a sphere, okay? So just sketch it. This is our nice little sphere. Now, what is a hemisphere? Okay? If this is a sphere, what is a hemisphere? Okay, sphere is just like a ball, right? A hemisphere is basically a sphere that has been cut in half. Okay? So if you cut this entire sphere in half, what you end up with is a hemisphere. Okay? So let me just do this. Alright, so I just took this sphere right here and I cut it in half, and then what we have is a hemisphere. Okay? Alright, so that's the relationship. So this is a sphere and this is a hemisphere. Okay? And a hemisphere is basically a sphere that has been divided by 2. Sphere over 2, or you can write it as 1/2 of a sphere. Okay? Alright, so now that we know the relationship between a sphere and a hemisphere, we can write down what the formula is. The formula for the volume. So, let's write it down. Formula for the volume of a hemisphere. volume of a hemisphere. Okay, so the formula for the volume of a hemisphere, let's just call it V of Hemi, is equal to 1/2 the volume of a sphere. So what's the volume of a sphere? The volume of a sphere is 4/3 pi r cubed. Okay, so the volume of a hemisphere is going to be half of that. It's going to be half of 4/3 pi r cubed. And if we simplify that, we will get, so 2 goes there, 1, 2 goes there, so we can divide it out. Well, let me show you the steps. It's going to be 4/6 pi r cubed, which reduces 2, divide top and bottom by 2. If you divide top and bottom by 2, you end up with 2/3 pi r cubed for the volume of a hemisphere. In this particular problem, we're given the diameter, okay? This formula asks for the radius, and we know that the radius is equal to the diameter divided by 2. Okay, so radius is diameter over 2. So the diameter is 12.6. All we just do is divide that by 2, okay? 12.6 divided by 2 is 6.3. Now we are ready to find the volume, because the only variable we need to find the volume of a hemisphere is the radius, and we have it already. Okay, so V is equal to, let's write down the formula again, 2/3 pi r cubed. I'm going to plug in r here, so you have 2/3 times pi times 6.3 raised to the third power. Okay, all right, let's fire up our calculators and compute what the volume is. So we have parentheses 2 divided by 3 times pi, second function caret, times 6.3 raised to the third power. Okay, so we have 523.7 to the nearest tenth. So it's 523.7. 523.7 cubic centimeter. The answer to question number 10 is option number 1. Alright, so in this particular problem, we use the formula for the volume of a hemisphere to find the volume of the hemisphere, okay? But is there a different way to do this problem? Could we possibly have found the volume of a sphere first and then proceeded from there? Let us know what you think in the comment section below. Is there a different way to approach this problem other than using this particular formula here, 2/3 pi r cubed, the volume of a hemisphere? Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for your geometry exam, do give us a thumbs up. Your positive feedback is extremely valuable to us. We'll also like to know what you think about this tutorial, or if you have any questions or comments, just put it in the comment section below, and we'll be more than glad to respond. Do not forget to subscribe to our channel for updates to the remainder of this review series. More support resources can be found at Mathgotserved.com. Do check it out. Thanks again for watching, and have a wonderful day. Goodbye.